Okay, this video will be on section 1.1, which is measuring and constructing segments. What you're looking at now is the key vocabulary for this particular unit, and I'm not actually going to go through each term right now, but throughout class, as well as the notes and worksheets that you guys are going to get in the next couple of days, you'll get all this information. Also, feel free to look in your book just in case if you want to skip ahead. All right, let's get started. The first thing that we're going to be talking about is finding the distance of 2 points that are on a number line. Now, the one thing I want to bring to your attention is this information right up here. You have, let's say the first question is A and B, and we're trying to find the distance, which is the absolute value of the distance of the coordinates of the points. Notice that we have the absolute value symbols here. Okay, and hopefully you remember exactly what absolute value is. It's the distance between whatever number's in those brackets to 0. Now also notice that you could write it either way. Since you're dealing with absolute value, it could either be, in this first example, A minus B or B minus A. Let's get started. For example number 1, we are to find the length of DC. Well, D is right here and C is right here. Now, since D is written first, I'm just going to go ahead and use D's point first. So that would be absolute value of 4.5 minus 2. So this is to find DC. So when we do this, when we do the math, we get absolute value of positive 2.5, which is 2.5 after we apply the absolute value principle. But let's say if you wanted to do it in the reverse way, which is CD, which CD would be 2, absolute value of 2 minus 4.5. When we do the math, we get absolute value of negative 2.5, which ends up being 2.5. Either way, you're going to get the same answer. The only thing to remember is that you're always dealing with subtracting the difference of the 2 points as well as using the absolute value symbols. So please remember that as you go through section or example problems 2 and 3. Also, feel free to pause the video to work the math beforehand, and then I'll be happy to show you how to do it once you hit play again. So, problems 2 and 3. So for example number 2, I went ahead and jumped ahead and put all my work down. Started with E, which is negative 4, and then F, which is negative 1. Now, hopefully you guys remember how to add and subtract negative numbers. When you have a double negative here, subtract negative, those become positive, which gives you negative 3, which at the end gives you positive 3. Okay. Now, for problem number 3, F and D. F and D, since I'm running out of room, I'll write it right here. You have negative 1 minus 4.5. Well, when I subtract, I get negative 5.5, which ends up being positive 5.5. Let's move on. Now, when we're dealing with geometry, we're going to be dealing with different types of symbols. What we're going to be talking about first is congruent segments. Congruent segments are segments that have the same length. Now, when you are dealing with a diagram or a picture, if you notice a little tick mark, a little hash in the middle of a side or maybe even an angle, but we'll deal with that later, these represent a congruent set of shapes, or in this case, line segments. So not even knowing the actual distance between M or P and Q, I know that because this tick mark is the same of this tick mark, I know that both these segments are the exact same. Now, down here at the bottom, we're talking about constructions. We're going to skip that for now, and we'll come back to that at a later date. All right, the segment addition postulate. A segment addition postulate is very easy to understand because basically what it means is that if you have a long segment, now notice up here in the example you have A and C. Well, if you cut A and C by a point, which in this case A and C is being cut by point B, what it states is that if you took this part of the segment and then you took this part of the segment, If you took these two pieces and added them together, you would get the length of the entire segment. Let's look at example number 2. It says G is between F and H. FG is 6 and FH is 11. Find GH. Well, if you notice, we do not have any type of picture to go off of. So let me encourage you to create your own picture to visually see the problem. So G is between F and H. So that would be, F would be right here. There's my point. Let's just go ahead and put G in the middle of it. And H here. Now I said in the middle. I shouldn't have said that. It's in between. It says that FG is, the distance of FG is 6, and the entire thing, F all the way to H, is 11. We are to find GH. Well, using the segment addition postulate, it would be 6 plus X, the two segments, would add up to the whole thing, which is 11. Well, using algebra, we know that X is going to equal 5. Now, doing something that I know students do not like doing is checking your work. So if we took 5 and plugged it back into the problem, 6 plus 5 equals 11. Good. Now, we have to raise the level of difficulty and start putting 3x minus 1, a bunch of expressions. Let's see, E is between D and F. Find DF. Well, once again, using the segment addition postulate, we would take 3x minus 1 and add it to 13 to get 6x. Now, whenever you're dealing with a situation where a binomial is inside a parenthesis, you have to take what's on the outside of the parenthesis and distribute it in. Well, outside of this parenthesis is a unseen positive 1. Well, when I distribute that inside the parenthesis, nothing changes, so technically I didn't even have to write the parenthesis, but it's always good to have good math skills. So I'm at 3x minus 1 plus 13 equals 6x. Now, using the rules of algebra and combining like terms, I'm going to subtract 3x from both sides, and I'm going to combine the negative 1 and positive 13, which gives us 12 equals 3x. Now, at this point, it should be pretty simple. I'm going to divide by 3, and then x would equal 4. Okay? Now, most math students would say, I'm done. But unfortunately, in Coach Ford's class, you have to check your work. So when I take this 4 and plug it back into this problem, that would be 3 times 4 minus 1. This gives us, 3 times 4 is 12 minus 1. This gives us 11. We have 13, so 11 plus 13. Let's see, 4 times 6, that gives us 24. So 11 plus 13 gives us 24. Your answer is good because you checked your work. Congratulations. All right, now you do this problem here. Now you're pretty much going to do the same exact thing except there's a different problem. Please be sure to check this correctly or check your work as you're setting everything up. Pause the video if you have to, and then I'll show you how to do it. So this is how you should set it up. 17 plus 3x minus 5 equals 5x plus 2. Once again, we're dealing with a parenthesis situation. There's an unseen positive 1 out here, so when I apply that, it becomes 17 plus 3x minus 5 equals 5x plus 2. When I combine like terms, I'm going to take the 3x, I'm going to bring this over to the right-hand side, and I'm going to take this positive 2 and subtract it and bring it over to the left-hand side. So when I combine like terms, I would get, this would cancel out, this would cancel out. It becomes 10 is equal to 2x to where x is equal to 5. Now, once again, you cannot go off of face value. You've got to go and check your work. So when I plug this in, that becomes 27. This here becomes 10. So 17 plus 10 gives us 27. We are correct. All right, moving on. Midpoints and bisectors. Well, midpoint is defined as a point that divides a segment into two congruent segments. Notice, once again, the symbols here, the tick marks. We know that AB and BC are exactly the same length. They are congruent. And to bisect something is to divide it into two congruent parts, or two equal parts. A segment bisector is a line, array, or segment that divides a segment into two congruent segments. So like what we have here with this example. We have line CD bisecting line segment AB. And I know it bisects because, once again, we have our symbols. All right. It says that S is the midpoint of line segment RT. So we're not given a diagram, we're not given a picture, so I'm going to make one. It just makes things easier. So it says S is the midpoint. I'm going to try my best to put the midpoint there of RT. That's R. And this will be T here. Now, it's congruent because it tells us it is congruent off of the fact that we're dealing with the midpoint. So that will be congruent to that. RS is negative 2x. ST is negative 3x minus 2. It says find RS, ST, and RT. So find the whole thing. Well, since I know that these are exactly the same, what I can do is I can set this information equal to each other. Negative 2x is equal to negative 3x minus 2. So when I combine like terms, I'm going to add 3x to this side. That gives us x is equal to negative 2. That should be our answer, but let's check our work to see. So when I plug in negative 2 in for RS, I get positive 4. When I plug in negative 2 into ST, I also get positive 4. So it is checked out, it works, we're going to go with that answer. Now you do this problem down here where D is the midpoint of EF. So from here, take it away. Now let me once again encourage you to draw a picture. Drawing a picture helps you visualize the problem, and it makes math more enjoyable for you and those around you. So feel free to pause this video and work through this problem before I explain it. All right, these are exactly the same, so I know that I can set both these equal to each other and I'll be okay. So 4x plus 6 is equal to 7x minus 9. So when I combine like terms, I'm going to subtract the 4x here, and I'm going to add the 9. I'm going to do this all in one step. When I do that, this cancels out, this cancels out. I'm left with 15 is equal to 3x. X should equal 5. I haven't checked my work, so I can only hope. So when I check my work, this becomes 26, I believe. 5 times 7 minus 9, that gives me 26. I am good. I'm going to go with that answer. All right. Next slide is an assignment for you guys to do. Page 11 through 12, problems 14, 29, 31, 33, and 34. Good luck with that, and please ask me any questions when you see me tomorrow. Thank you.